Welcome. You are here, and that is enough. Thank you for choosing to spend this quiet moment together. Before we begin, gently consider supporting this channel. If these calm science journeys help you relax, you may like this video and subscribe. Now, let everything else fade. There is nowhere else you need to be. Tonight we are going to talk about something that cannot be seen. Something that does not shine, glow, or reflect light. Something that moves silently through the universe, unnoticed, yet deeply important. This video is about dark matter. Not the dramatic kind, not the mysterious version filled with fear or excitement, but the quiet, patient dark matter that calmly holds galaxies together. Dark matter does not rush. It does not sparkle. It does not announce its presence. And because of that, it is perfect for a slow and restful journey. In the universe around us, almost everything we see is made of light. Stars glow softly in the distance. Galaxies stretch across the dark like gentle brush strokes. Nebulae drift quietly, glowing faintly in colors we can barely imagine. But behind all of that light, there is something else. Something much more common, something far more widespread. Most of the universe is not made of stars. It is not made of planets. It is not made of glowing clouds of gas. Most of the universe is made of something invisible. Dark matter does not block light. It does not reflect it. It simply allows light to pass through, as if nothing were there at all. And yet, even though we cannot see it, dark matter has weight. It has mass. It gently pulls on the things around it. Because of this soft pull, galaxies stay together. Because of this invisible presence, stars move in calm, predictable paths. Because of this quiet force, the universe remains balanced. In this video, we will take our time exploring that balance. There is no rush here. No need to remember everything. No need to understand every detail. Each chapter will move slowly. Each idea will arrive gently. And if you fall asleep along the way, that is perfectly fine. You do not need to stay awake to enjoy this journey. We will talk about how dark matter was first noticed. Not through bright discoveries, but through small, quiet observations. Through careful watching. Through patience. We will explore how scientists realized that galaxies were heavier than they appeared. How stars were moving as if guided by something unseen. How invisible mass was quietly shaping the cosmos. We will also talk about what dark matter is not. It is not darkness itself. It is not empty space. It is not shadow or absence. It is something real. Something present. Something calmly existing all around us, even now. As this video continues, the explanations will remain soft. There will be no complicated equations. No overwhelming numbers. No heavy scientific language. Only simple ideas, quiet motion. Gentle gravity. You may listen with your eyes closed. You may let the images pass without focus. You may allow your thoughts to slow, just as the universe itself moves slowly. Dark matter has been here for billions of years. It is in no hurry. And neither are we. So settle in. Adjust your volume to something comfortable. Let the background noise fade away. We are about to begin a calm journey through one of the universe's quietest mysteries. And we will take all the time we need. The idea of something we cannot see. When we look out into the universe, almost everything we understand begins with light. We learn by watching. We measure by observing. We trust what reaches our eyes, even across vast distances. Stars shine. Galaxies glow softly. Nebulae drift like quiet clouds, painted with faint colors. For a very long time, scientists believed that this light told the whole story of the universe. But slowly, gently, that idea began to change. The first clue was not dramatic. There was no sudden discovery. No bright flash in the sky. Instead, there was a quiet mismatch between what was seen and what was felt. Galaxies were moving in ways that seemed slightly off. Stars near the edges of galaxies were traveling faster than expected. According to what could be seen, those stars should have drifted away into space. Yet they did not. They stayed. This suggested that something else was there. Something invisible. Something adding weight without adding light. Dark matter was not discovered by looking directly at it. It was discovered by noticing what should not have been possible. When scientists calculated how much mass a galaxy should have, based on the light it produced, the numbers came up short. There was not enough visible material to hold the galaxy together. And still, the galaxy remained calm and intact. This told us something important. Light alone does not tell the full story of mass. Brightness is not the same as weight. There are things in the universe that exist without glowing. There are forms of matter that do not shine, burn, or reflect light at all. Dark matter belongs to this quiet category. It does not emit light. It does not absorb light. It does not scatter light. Light passes through it almost as if it were empty space. But it is not empty. Dark matter has mass. And mass creates gravity. This gravity is gentle, but persistent. It does not push. It only pulls. And over long periods of time, even the softest pull can shape entire galaxies. One way to imagine dark matter is to think of wind. You cannot see the wind itself. But you can see leaves move. You can feel pressure against your skin. You can watch clouds shift slowly across the sky. In the same way, scientists do not see dark matter directly. They see its effects. They feel its presence through motion and balance. Another way to think of it is like scaffolding. Before a building takes shape, scaffolding supports the structure. Once the building is complete, the scaffolding may not be visible, but its influence remains in the final form. Dark matter acts as a kind of cosmic scaffolding. It provides the invisible framework around which galaxies slowly form. Without it, galaxies would not have enough structure to exist as they do. Stars would drift apart. Galactic shapes would dissolve over time. Yet with dark matter present, everything stays calmly arranged. It is important to understand what dark matter is not. It is not simply darkness. Darkness is the absence of light. Dark matter is the presence of mass. It is also not the same as empty space. Empty space still has energy and activity. Dark matter is something more defined, more substantial. It is not made of ordinary atoms like stars, planets, or people. It does not form molecules. It does not create chemistry. Dark matter seems to pass through normal matter without interacting in noticeable ways. Your body is likely moving through dark matter right now, without any sensation at all. This may sound strange, but it is also comforting. The universe is full of things that exist quietly, without interruption. Dark matter does not collide loudly. It does not react. It simply exists, and through its existence, it shapes everything else. As we move forward, we will explore how scientists learn to measure something they cannot see, how motion becomes a language, how gravity becomes a clue. For now, it is enough to rest with this idea. The universe contains more than what is visible, more than what shines, more than what calls attention to itself. Much of it works silently, patiently, and without display, and dark matter is one of the quietest examples of this truth. How scientists first noticed something was missing. Long before dark matter had a name, there was only a quiet sense that something did not fit. The universe looked calm and orderly, but careful measurements told a different story. In the early 20th century, astronomers began studying how stars moved inside galaxies. They expected these movements to follow simple rules. Stars closer to the center should move faster. Stars farther away should move more slowly, just as planets move around the sun. At first, this seemed reasonable. Light showed where the stars were. Gravity, it was assumed, came only from the matter that could be seen. But when scientists measured the speeds of stars at the outer edges of galaxies, the results were surprising. Those distant stars were moving just as fast as the stars near the center. According to known physics, this should not have been possible. If only visible matter were present, the outer stars should have drifted away into space. Yet they did not. This was the first quiet sign that something unseen was adding weight to galaxies. One of the earliest scientists to notice this pattern was Fritz Zwicky. While studying clusters of galaxies, he calculated how much mass was needed to keep them bound together. The visible matter was not enough. There was far more gravity than light could explain. Zwicky called this missing mass dark matter, not because it was evil or mysterious, but because it did not shine. At the time, his idea was largely ignored. The universe did not seem eager to give up its secrets. For many years, the idea rested quietly, waiting. Later, more careful observations confirmed the same problem. As telescopes improved, scientists could measure galaxy rotation with greater precision. Again and again, the same pattern appeared. Galaxies were heavier than they looked. This realization did not arrive all at once. It came slowly, through repeated calm observations. Each new galaxy studied added to the same quiet conclusion. There was more mass present than could be seen. The beauty of this discovery lies in its patience. No single observation forced the answer. Instead, the universe whispered the same message over and over. Stars were moving too fast. Galaxies were holding together too well. Something invisible was providing extra gravity. Scientists had to accept a gentle but profound idea. Not everything important announces itself with light. This changed how we think about observation. Seeing is not always believing. Sometimes, movement tells the deeper story. Gravity became the key. Gravity does not care whether matter glows or stays dark. It responds only to mass. By watching how objects moved, scientists could trace the outline of something they could not see. This was not guesswork. It was careful listening to the universe's behavior. Dark matter was never captured in a photograph. It was inferred patiently through patterns that refused to disappear. Over time, the evidence became impossible to ignore. Different galaxies, different clusters, different measurements, all pointed to the same invisible presence. What began as a small inconsistency grew into a central idea of modern cosmology. And still, dark matter remained quiet. It did not reveal its nature. It did not interact with instruments directly. It simply continued to hold galaxies together, as it always had. This chapter of discovery teaches something gentle and important. Understanding does not always come from dramatic breakthroughs. Sometimes it comes from noticing what should not be missing, and realizing that it is. Why galaxies move in a calm but strange way. Galaxies appear peaceful when we observe them from afar. They drift slowly through space, rotating with a quiet, steady rhythm. Nothing about them looks rushed or unstable. Yet beneath this calm appearance, there is a gentle mystery in their motion. When scientists began measuring how galaxies rotate, they expected to see a familiar pattern. Stars closer to the center of a galaxy should move more quickly, where gravity is strongest. Stars farther away should move more slowly, where gravity weakens. This is how motion works in many systems we understand. Planets near the Sun orbit faster. Those farther away move more gently. But galaxies did not follow this pattern. Instead, something unexpected happened. Stars at the outer edges of galaxies were moving just as fast as stars near the center. The speed did not decrease with distance. This was strange, but not chaotic. The motion was smooth, stable, almost too perfect. If galaxies were made only of the matter we can see, this calm rotation should not exist. Outer stars should slowly drift away, pulled too weakly by visible mass alone. Yet galaxies remained whole. This suggested that gravity was stronger than it appeared. Not violent. Not abrupt. Just quietly present everywhere. Dark matter offered a gentle explanation. Instead of being concentrated only where stars shine, dark matter seems to surround galaxies in vast, invisible halos. These halos extend far beyond the glowing edges of galaxies. Within this invisible envelope, gravity remains strong even at great distances. Stars feel a steady pull, no matter how far they orbit from the center. This is why galaxies rotate in such a calm but unusual way. The motion is not random. It is balanced. Each star follows a stable path, guided by gravity that does not fade as expected. To imagine this, think of a lake on a still night. If the water were shallow only at the center, ripples would fade near the edges. But if the lake were deep everywhere, the ripples would move smoothly across its surface. Dark matter creates a kind of deep gravitational lake around galaxies. The stars move within it, unaware of the invisible depth beneath them. This also explains why galaxies can be so large. They are not fragile structures held together by visible matter alone. They are supported by something much more extensive. Dark matter does not form bright arms or glowing cores. It does not clump into stars. Instead, it spreads out, forming a wide and quiet presence. Because of this, galaxies can rotate for billions of years without tearing themselves apart. There is something deeply calming about this idea. An unseen structure providing stability. A gentle force working continuously, without interruption. Galaxies do not struggle against gravity. They move with it. They follow paths shaped by invisible support. As scientists observed more galaxies, this same calm but strange rotation appeared again and again. Spiral galaxies, elliptical galaxies, large ones, small ones, all seem to be wrapped in something unseen. This consistency strengthened the idea of dark matter, not as a rare exception, but as a common feature of the universe. It suggested that what we see is only a small part of what exists. That light reveals shapes, but gravity reveals truth. And in the slow, steady motion of galaxies, the universe quietly showed us that something invisible was guiding the dance. The gentle pull that holds galaxies together. Gravity is often described as a force, but in the universe, it behaves more like a quiet guide. It does not shout. It does not rush. It simply draws things together, patiently and endlessly. In galaxies, this gentle pull is everywhere. Every star feels it. Every cloud of gas responds to it. Even the faint dust between stars follows its influence. For a long time, scientists believed that the gravity holding galaxies together came only from visible matter. From stars. From glowing gas. From planets and dust, but as we have already begun to see, this was not enough. The visible matter in a galaxy does not weigh nearly enough to explain its stability. If gravity came only from what we can see, galaxies would be fragile. They would slowly unravel over time. Yet they do not. Galaxies remain calm and intact for billions of years. This is where dark matter quietly enters the story. Dark matter adds weight without adding light. It contributes mass without contributing brightness. And because gravity responds only to mass, dark matter becomes a silent but powerful participant. Unlike stars, dark matter does not clump into bright points. It spreads out, forming large, smooth halos around galaxies. These halos are vast, extending far beyond the visible edges of galactic disks. Within these halos, gravity remains steady and evenly distributed. This steady pull is what allows galaxies to rotate without tearing themselves apart. Stars at the edges do not fly off into space. Gas clouds do not drift away. Everything remains gently bound. It is important to understand that this pull is not aggressive. Dark matter does not drag stars inward violently. It does not cause sudden collapse. Instead, it creates a calm gravitational environment. A balanced field in which motion can remain smooth and predictable. Think of it like a slow-moving river. The water guides floating leaves without turbulence. Nothing is forced. Everything simply follows the flow. Dark matter works in a similar way. Its gravity shapes the paths of stars over immense spans of time. So slow that nothing feels sudden. So constant that nothing feels unstable. Even when galaxies interact with one another, dark matter plays a quiet role. As galaxies pass nearby or gently merge, their dark matter halos overlap first. They sense each other long before their visible parts touch. This invisible interaction helps guide how galaxies settle into new shapes. It cushions their encounters. It distributes mass evenly. Without dark matter, galaxy interactions would be far more chaotic. Stars would scatter more easily. Structures would be less defined. But with dark matter present, the universe remains orderly. There is also a subtle comfort in knowing that most of the gravity shaping the cosmos comes from something calm and invisible, not from explosions, not from violent collisions, but from a steady presence that never demands attention. Dark matter does not shine. It does not flare. It does not announce itself. And yet, without it, the universe would look very different. Galaxies would be smaller. less stable, short-lived. The grand structures we see today owe their existence to something that never glows. This teaches us something quiet and important. Not all support is visible. Not all structure announces itself. Sometimes, the most important things are the ones that work silently in the background. As we continue our journey, we will see how this gentle pull not only holds galaxies together, but also shaped them from the very beginning. For now, it is enough to rest with this idea. A calm, invisible presence, holding everything in place, without ever being seen. What dark matter is not. When people first hear the words dark matter, the name itself can create confusion. It sounds heavy. It sounds mysterious. It sounds as if it describes something dangerous or unknown. But understanding dark matter begins by gently clearing away what it is not. Dark matter is not darkness itself. Darkness is simply the absence of light. When a room is dark, it is not filled with a substance called darkness. It is simply missing light. Dark matter is different. It is something that exists, even when light is present. Dark matter is also not shadow. A shadow is created when light is blocked by an object. Dark matter does not block light in this way. Light passes through it almost untouched. Because of this, dark matter cannot be seen, even indirectly. It is not made of dust. Dust reflects and absorbs light. Dark matter does either. It is also not made of gas. Gas glows when it becomes hot. Dark matter does not glow, no matter how much time passes. Dark matter is not a planet, a star, or a black hole. Those objects are made of ordinary matter. They interact with light and can be detected through telescopes. Dark matter does not form solid surfaces. It does not create clouds. It does not gather into visible shapes. Another common misunderstanding is that dark matter is the same as empty space. Empty space may look blank, but it is full of energy, radiation, and particles. Dark matter is something added on top of that emptiness. It contributes mass where there would otherwise be none. Dark matter is also not dangerous in the way people often imagine. It does not tear things apart. It does not pull objects violently toward it. Even though dark matter surrounds galaxies, it does not interfere with everyday life. It passes through planets, stars, and people without notice. Right now, dark matter is likely passing through your body, and you feel nothing at all. This does not mean dark matter is weak. It simply means it interacts very differently from the matter we are familiar with. Dark matter does not participate in chemical reactions. It does not form atoms. It does not build molecules. This is why it does not create light, heat, or structure on small scales. It also means that dark matter cannot be held, collected, or stored using ordinary tools. It cannot be captured in a container. It cannot be observed directly in a laboratory. Understanding what dark matter is not helps narrow the possibilities of what it might be. It tells scientists where not to look. It gently guides research away from familiar forms of matter. And in doing so, it reminds us that the universe contains more than what fits neatly into our everyday categories. Dark matter exists quietly, outside our senses, shaping the cosmos without ever making itself known through light. Sometimes, understanding begins not with adding new ideas, but with slowly removing the wrong ones. And in the quiet space left behind, clarity begins to form. Why dark matter does not glow. Light is one of the most familiar ways we understand the universe. When something exists, we expect it to shine, reflect, or at least block light in some way. Stars glow. Planets reflect sunlight. Even dust becomes visible when light touches it. Dark matter does none of these things. This is one of its most defining features. Dark matter does not glow because it does not interact with light in the usual ways. It does not emit light. It does not absorb light. It does not scatter light. Photons, the tiny particles of light, pass through dark matter almost as if nothing were there. This may feel strange, but it tells us something important. Ordinary matter is made of atoms. Atoms have charged particles inside them, such as electrons. When light meets these charges, interactions happen. Light can be absorbed, reflected, or released. Dark matter does not appear to have this structure. If dark matter had electric charge, it would interact with light. If it formed atoms like normal matter, it would glow or block light. But it does not. This suggests that dark matter is made of particles very different from the ones that make up stars, planets, and people. Because dark matter does not interact with light, telescopes cannot see it directly. No matter how powerful a telescope becomes, it will never capture an image of dark matter itself. Instead, scientists look for its presence in other ways. They watch how stars move. They observe how galaxies bend light from distant objects. They measure how clusters of galaxies behave. All of these effects come from gravity, not light. Gravity does not care whether something glows or stays dark. It responds only to mass. Dark matter has mass, even though it has no light. This is why it can shape galaxies while remaining invisible. There is a quiet elegance in this idea. Something can be deeply important without ever being seen. Dark matter does not announce itself with brightness. It does not draw attention. It simply exists and influences everything around it. This is also why dark matter remained hidden for so long. Human observation has always depended heavily on light. What cannot be seen is easy to overlook, but the universe is not designed for human convenience. It does not reveal all its parts in familiar ways. Dark matter reminds us of this gently. It shows us that visibility is not a requirement for reality. Something can be real, powerful, and widespread, without ever glowing. In a way, dark matter is patient. It does not demand discovery. It allows itself to be noticed only through long, careful observation. As technology improves, scientists continue to design experiments that listen for dark matter rather than look for it. They wait for tiny interactions. They measure subtle effects. But even if dark matter is never directly detected, its influence is already clear. Galaxies move as they do because dark matter is there. Clusters remain bound because dark matter adds weight. The large-scale structure of the universe depends on it. All of this happens without a single ray of light being produced. Dark matter teaches us a quiet lesson. Not everything that matters shines. Not everything that shapes reality asks to be seen. Some things work best in silence. And as we continue this journey, we will see how this silent presence moves through the universe, untouched by light, yet deeply connected to everything it holds together. The difference between darkness and invisibility. At first glance, darkness and invisibility may seem like the same thing. Both suggest an absence. Both suggest something missing from view. But in the universe, these two ideas are very different. Darkness is simply a lack of light. When a place is dark, it means light has not reached it yet. A cave is dark because sunlight cannot enter. Deep space looks dark because stars are far apart, and light is spread thin. Darkness can disappear instantly. Turn on a light, and darkness is gone. Invisibility is different. Invisibility does not depend on light being present or absent. Something invisible can exist even in bright daylight. It can sit in the middle of a glowing room and still remain unseen. Dark matter belongs to the second category. It is not hidden by darkness. It does not wait for light. Even if the universe were filled with brightness, dark matter would still remain unseen. This is because dark matter does not interact with light at all. Light does not bounce off it. Light does not get absorbed by it. Light does not reveal its shape or position. It is not that dark matter is hiding, it is simply not participating. To understand this, imagine sound instead of light. A soundproof room can be full of activity, yet remain silent to the outside. The silence does not mean nothing is happening inside. It only means sound cannot pass through. Dark matter is similar, but with light. It exists in the same space as stars and galaxies. It overlaps with them. It surrounds them. Yet light moves through it without noticing. This is why dark matter remained unknown for so long. Our tools were designed to detect brightness. We learned to map the universe by tracing light, but the universe contains more than light. When scientists finally understood this difference, it changed how they searched. Instead of asking, "What can we see?" they began asking, What can we measure without seeing? Gravity became the answer. Gravity does not need light. It does not depend on visibility. It responds to mass alone. By observing how gravity affects visible objects, scientists could detect the presence of something invisible. This is a quiet shift in thinking. It teaches us that absence of light does not mean absence of substance. Something can be fully present, fully real, and completely unseen. In daily life, we rarely experience true invisibility. Most things around us interact with light in some way. They reflect, absorb, or block it. Dark matter does none of these things. It flows through galaxies like a calm, invisible ocean. Stars move within it. Galaxies float inside it. Yet it never reveals itself to our eyes. There is something strangely peaceful about this idea. A presence that does not interrupt. A substance that supports without displaying itself. Dark matter does not demand attention. It does not compete with stars for brightness. It simply exists, quietly doing its work. Understanding the difference between darkness and invisibility helps us let go of a common misunderstanding. Dark matter is not hidden in shadows. It is not lurking in dark corners of space. It is everywhere, even where light is strongest. And in that realization, the universe feels larger, deeper, and more subtle than before. As we continue, we will see how this invisible presence moves freely through everything, untouched and undisturbed, yet always shaping what we can see. How dark matter passes through everything. One of the quietest and most remarkable qualities of dark matter is how easily it moves through the universe. Not around things. Not above them. But directly through them. Dark matter does not stop at the edges of stars. It does not slow down near planets. It does not avoid galaxies, clouds of gas, or living beings. It simply passes through. This may sound unsettling at first, but it is actually very gentle. Dark matter does not push. It does not scrape or collide in ways we can feel. It does not disturb the structure of ordinary matter. That is why its presence has gone unnoticed for so long. Everything we know and touch is made of ordinary matter. Atoms arranged into molecules. Molecules forming solids, liquids, and gases. These structures interact through forces like electricity and magnetism. Dark matter does not seem to participate in these interactions. It does not stick to atoms. It does not bounce off them. It does not slow down when passing through them. Because of this, dark matter can move freely through planets, stars, and even entire galaxies without leaving a trace we can easily detect. Right now, as you listen, dark matter may be flowing through the earth, through the walls around you, through your body, and nothing changes. This is not because dark matter is weak. It is because it interacts in a very limited way. The only force dark matter clearly responds to is gravity. Gravity works at a distance. It does not require contact. It does not need surfaces or collisions. So dark matter can influence galaxies from afar while remaining untouched by the smaller structures within them. This is why dark matter does not collect in the same places as ordinary matter. It does not settle into planets. It does not form stars. It does not gather into clouds. Instead, it remains spread out, flowing through space like a calm, invisible current. Scientists sometimes compare this to a faint mist drifting through a forest. The mist moves through trees without bending branches or breaking leaves. It is present, but not disruptive. Dark matter behaves in a similar way on a cosmic scale. Because it passes through everything, it is extremely difficult to capture. Experiments on Earth attempt to detect tiny, rare interactions between dark matter and ordinary particles. These experiments are quiet. They wait patiently. Most of the time, nothing happens. This does not mean dark matter is absent. It means it is simply passing through without interacting. This quality also explains why dark matter does not slow down over time. It does not lose energy by colliding with other matter. It continues moving, orbiting galaxies and clusters as it has for billions of years. There is a steady calmness in this behavior. Dark matter does not settle. It does not cling. It does not resist. It moves through the universe with a kind of quiet permission, never asking space to make room for it. Understanding this helps explain why dark matter is so difficult to study directly. It leaves no marks. It creates no light. It does not announce itself. And yet, its influence is everywhere. Galaxies rotate because dark matter is there. Clusters remain bound because dark matter flows through them. The large-scale structure of the universe depends on this invisible movement. Dark matter does not need to be seen to be effective. It simply passes through, gently shaping the universe as it goes. As we continue, we will explore why this lack of interaction makes dark matter both difficult to detect and deeply fascinating. For now, it is enough to rest with this idea. Something can be everywhere, moving through everything, and still remain completely unnoticed. Why dark matter rarely interacts. In the universe, most things interact often. Particles collide. Light reflects. Forces push and pull in many directions. Dark matter is different. It is defined not by what it does, but by how little it does. Dark matter rarely interacts with anything other than gravity. It does not form bonds. It does not exchange energy in noticeable ways. It does not respond to electric or magnetic forces. Because of this, dark matter remains almost entirely separate from the familiar world of ordinary matter. To understand this, it helps to think about interaction itself. When two objects interact, something is exchanged. Energy, momentum, or information passes between them. For example, when light hits a surface, energy is absorbed or reflected. When particles collide, they push or change direction. Dark matter seems to avoid these exchanges. Its particles, whatever they are, move through space as if ordinary matter is not there. They do not slow down. They do not scatter. This is why dark matter has not been detected in the same way as other particles. Detectors are designed to catch interactions. They wait for impacts, flashes, or tiny bursts of energy. Dark matter provides almost none of these signals. This does not mean scientists are not looking. On the contrary, they have built extremely sensitive experiments deep underground, far from noise and interference. These experiments wait quietly, sometimes for years. They listen for the faintest signs of interaction. Most of the time, they hear nothing. This silence itself is meaningful. It tells scientists that if dark matter interacts at all, it does so very rarely. This rare interaction is part of what makes dark matter stable. Because it does not collide often, it does not lose energy. Because it does not clump easily, it remains spread out. Over billions of years, this stability allows dark matter to form vast halos around galaxies. These halos remain smooth and persistent, unlike ordinary matter, which changes and evolves. There is a calmness in this behavior. Dark matter does not rush toward complexity. It does not seek structure on small scales. It is content to remain diffuse, shaping the universe gently from the background. This also means dark matter does not heat up or cool down in familiar ways. Temperature is a measure of interaction and motion among particles. With so few interactions, dark matter does not easily share heat. It exists outside many of the processes that define ordinary matter. Because of this, dark matter acts as a steady foundation for cosmic structures. Stars form and burn out. Gas clouds collapse and disperse. But dark matter remains largely unchanged. Its rare interactions make it patient, unchanging, reliable. In a universe full of movement and transformation, dark matter offers quiet consistency. And while scientists continue to search for ways to detect it directly, dark matter continues to do what it has always done. It holds galaxies together. It guides motion without interference. It interacts just enough to matter, and no more. As we move forward, we will see how this rare interaction shapes the large-scale structure of the universe itself. For now, let the idea rest. Something can influence everything, while barely touching anything at all. Watching stars move quietly. Much of what we know about dark matter comes from watching stars. Not in moments of drama. Not during sudden explosions. But during long, quiet periods of steady motion. Stars move slowly. From our perspective, their journeys take millions of years. But with careful measurement, Their paths reveal important truths. Astronomers track how stars orbit within galaxies. They measure speed. They measure direction. They note how these movements change with distance from the center. These measurements require patience. Nothing happens quickly. The universe does not hurry. When scientists map these motions, a calm pattern appears. Stars follow smooth, stable paths. Their orbits do not wobble or break apart. But there is something curious in this calmness. As stars move farther from the center of a galaxy, they do not slow down as expected. Their speeds remain nearly constant. This quiet consistency suggests that gravity remains strong even far from visible matter. If gravity came only from stars and glowing gas, this would not be possible. Something unseen must be contributing. By observing many stars at many distances, scientists can build a picture of how mass is distributed throughout a galaxy. This picture does not match what light alone reveals. There is more mass than light can explain. This method of discovery is indirect, but reliable. It does not rely on speculation. It relies on motion. Motion does not lie. Objects move in response to forces, whether we can see the source or not. Stars act as gentle messengers. They respond to gravity without knowing its origin. They trace invisible structures simply by following their paths. This is how dark matter makes itself known. Not through brightness. Not through sound. But through quiet guidance. Each star is like a small test particle, moving through a gravitational field shaped by both visible and invisible matter. By observing thousands of stars, scientists can map the invisible. This process takes time. It requires steady observation. It rewards patience. There is something fitting about this. Dark matter, which works quietly, is discovered through quiet observation. No sudden moments of revelation are needed. Just careful attention. As telescopes become more precise, this picture grows clearer. The invisible mass extends well beyond the visible edge of galaxies. It forms wide halos that cradle stars in gentle orbits. These halos are smooth. They do not fluctuate wildly. They provide consistent support. This stability explains why galaxies survive for billions of years without falling apart. It also explains why dark matter is believed to be present in nearly every galaxy. Where stars move calmly, dark matter is there. Watching stars move quietly teaches us an important lesson. Not all evidence is loud. Not all truth announces itself. Sometimes, understanding comes from watching patiently and noticing what never changes. The stars continue their slow journeys. The galaxies remain whole. And in their calm motion, the presence of dark matter becomes clear. As we move ahead, we will see how this same quiet evidence appears on even larger scales, beyond individual galaxies. For now, rest with this gentle image. Stars moving softly through space, guided by something unseen, yet always present. Galaxy rotation explained softly. When a galaxy turns, it does so with a slow and steady grace. From a distance, the motion looks almost still. But over time, the rotation reveals important details about what holds the galaxy together. Astronomers measure galaxy rotation by observing the light from stars and gas as they move toward or away from us. This movement slightly changes the light's color, allowing scientists to calculate speed. The method is careful and quiet. It does not disturb the galaxy. It simply listens. What these measurements show is both simple and surprising. Across much of a galaxy, the speed of rotation remains nearly the same. Stars near the center and stars far from it move at similar speeds. If gravity came only from visible matter, this would not happen. The outer regions should rotate more slowly, where less mass is present. But the universe chooses a different pattern. This steady rotation suggests that mass is spread evenly throughout the galaxy, far beyond the bright regions we can see. Dark matter provides this hidden mass. Instead of being concentrated in the center, dark matter forms a wide halo around the galaxy. This halo extends well past the visible edge, holding everything together. The result is a smooth, balanced rotation. No sharp changes. No instability. This behavior is seen in galaxies of many shapes and sizes. Spiral galaxies. Elliptical galaxies. Small galaxies. Large ones. This same quiet pattern appears again and again. This repetition strengthens the idea that dark matter is not rare. It is a common feature of the universe. Galaxy rotation curves, as scientists call them, provide one of the clearest pieces of evidence for dark matter. They are calm, consistent, and difficult to ignore. These curves do not rely on assumptions. They are built from direct observation. There is something peaceful about this evidence. It does not demand belief. It simply presents itself. The universe does not explain itself with words. It explains itself with motion. By watching how galaxies turn, scientists learn what they are made of, even when most of that material cannot be seen. This also reminds us that light tells only part of the story. Brightness shows us where stars are. Gravity shows us what truly exists. Dark matter quietly fills the space around galaxies, shaping their motion without ever appearing in the light they emit. The rotation of galaxies is like a slow dance. Every star moves in harmony with an unseen partner. That partner does not glow. It does not step forward. But without it, the dance would fall apart. As we continue, we will look beyond individual galaxies and see how this invisible mass shapes entire groups and clusters. For now, let the idea settle. A galaxy turning slowly in space. Stars moving together. Held in place by something invisible, yet deeply real. Clusters of galaxies and invisible weight. Beyond individual galaxies, the universe forms larger communities. Galaxies gather together in groups and clusters, moving slowly through vast regions of space. These clusters are some of the largest structures in the universe. They contain hundreds, sometimes thousands, of galaxies drifting together. At first glance, they appear calm and loosely connected. The distances between galaxies are enormous. Nothing seems tightly bound. And yet, these clusters remain together for billions of years. This quiet stability raises an important question. What holds such massive collections of galaxies together? When scientists measure the total light coming from a cluster, they can estimate how much visible matter it contains. Stars, glowing gas, and hot clouds contribute to this brightness. But when they calculate the gravity needed to keep the cluster bound, the visible matter again falls short. There is far more weight present than light can explain. Galaxies and clusters move faster than expected. Hot gas between galaxies stays trapped instead of drifting away. The entire structure behaves as if it contains much more mass than what can be seen. Dark matter provides a gentle answer. Just as it surrounds individual galaxies, dark matter also fills the space between them. In clusters, it forms a vast, invisible network that connects galaxies together. This network adds weight without adding light. Because of dark matter, clusters remain intact. Galaxies orbit a shared center of gravity. Hot gas stays gently contained. One of the clearest examples of this comes from observing how clusters bend light from objects behind them. Even though we cannot see the dark matter directly, its gravity reveals its presence. The light from distant galaxies curves as it passes through a cluster. This bending shows where mass is located, even when that mass does not glow. The resulting maps reveal something striking. Most of the mass in clusters is not in the stars or gas. It is in an invisible form. This discovery was not sudden. It emerged from careful, repeated observation. Cluster after cluster told the same quiet story. There is more there than meets the eye. Clusters teach us that dark matter is not confined to small scales. It operates on the largest structures in the universe. From single galaxies to massive clusters, the same invisible presence plays the same role. Holding, binding, stabilizing. This consistency strengthens the idea that dark matter is a fundamental part of the universe. Not a local oddity. Not a temporary effect. But a widespread and lasting component. There is a quiet beauty in this realization. The largest structures in existence are shaped by something we cannot see. Something that works without drawing attention. Clusters of galaxies float together, guided by invisible weight, moving slowly through cosmic time. As we continue, we will explore how this invisible mass bends light itself, allowing us to map the unseen in a calm and indirect way. For now, rest with this image. Many galaxies drifting together, held by something silent, steady, and unseen. Gravitational lensing without light. Light usually travels in straight, gentle lines. It moves calmly across space, carrying quiet information from distant places. But when light passes near something heavy, its path slowly curves. This bending of light is called gravitational lensing. It does not require mirrors. It does not require glass. It happens naturally, guided by gravity alone. When scientists observe distant galaxies through large clusters of matter, they sometimes notice something unusual. The galaxies behind appear stretched. Their shapes look slightly curved. Sometimes they form soft arcs or faint rings. This effect is subtle. It does not flash or glow. It requires patience to notice. The bending occurs because gravity gently curves the space that light moves through. Light simply follows that curve. What makes this especially interesting is that the bending does not depend on brightness. It depends only on mass. This means that even invisible matter can bend light. Dark matter does exactly this. Although dark matter cannot be seen, its gravity affects the space around it. As light from distant galaxies passes through regions filled with dark matter, its path curves quietly. By carefully measuring these distortions, scientists can map where mass exists, even when nothing is glowing. This method allows researchers to create gentle outlines of invisible structures. Not images in the usual sense, but gravitational impressions. The light itself becomes a messenger. It tells us where mass is present by how it bends and stretches as it passes by. In some cases, the bending is strong enough to create multiple images of the same distant object. In others, the effect is barely noticeable, detectable only through careful analysis. Both are valuable. Gravitational lensing shows that dark matter is not randomly scattered. It forms smooth, extended shapes around galaxies and clusters. These shapes align with the calm motion of stars and galaxies we have already observed. Once again, different forms of evidence point to the same invisible presence. There is something deeply quiet about this method of discovery. Light travels for billions of years. It passes silently through space. And in doing so, it reveals the unseen. Dark matter never blocks the light. It never absorbs it. It simply guides it, gently bending its path. This bending is not dramatic. It does not distort reality beyond recognition. It adds a soft curvature, like a slow ripple in water. Through gravitational lensing, scientists learn that dark matter is spread widely and smoothly. It does not form sharp edges. It does not create sudden boundaries. It exists as a calm, extended presence. This understanding helps explain why galaxies and clusters appear the way they do. Why structures in the universe are connected by invisible threads of mass. Lensing allows us to see the influence of dark matter without ever seeing the matter itself. It is a quiet kind of vision. No bright images. No direct contact. Just careful observation and patient interpretation. As we move forward, we will see how these invisible structures form a vast network across the universe, connecting galaxies over enormous distances. For now, let this idea rest. Light traveling calmly through space, gently bending, quietly revealing what cannot be seen. Seeing the unseen through motion. In the universe, motion is one of the most honest messengers. Objects move only when something guides them. They do not choose their paths. They follow the quiet rules set by gravity. This is why motion becomes such an important tool when studying dark matter. Dark matter does not shine. It does not leave visible marks. But it shapes motion everywhere it exists. By watching how objects move, scientists can trace the outline of something invisible. This idea appears again and again across cosmic scales. Stars orbit within galaxies. Galaxies drift within clusters. Clusters move within vast cosmic structures. At each level, the motion remains calm and organized. If dark matter were absent, these motions would look very different. Stars would escape their galaxies. Galaxies would drift apart from clusters. The universe would be far less structured. But that is not what we see. Instead, motion remains stable over immense periods of time. This stability tells us that gravity is present where light is not. Scientists often use computer models to simulate how galaxies would move without dark matter. In these models, structures fall apart quickly. The graceful patterns we observe disappear. When dark matter is included, the simulations suddenly resemble reality. The same calm rotation. The same long-lasting stability. The same gentle balance. Motion becomes a kind of map. Not a map drawn with ink or light, but one traced by time. Every orbit leaves an imprint. Every steady path reveals the presence of mass. This approach requires patience. Motion unfolds slowly. It cannot be rushed or forced. But this slowness is what makes the evidence reliable. Dark matter reveals itself not through sudden events, but through consistency. Over billions of years, the same patterns repeat. The same motions persist. This repetition builds confidence. There is also something peaceful about this method of discovery. Nothing is disturbed. Nothing is altered. Scientists simply watch. They allow the universe to speak through its movement. This approach reflects a deeper truth. Some things can only be understood by letting them unfold naturally. Dark matter does not respond to direct questions. It does not react to light or sound, but it responds to gravity, and gravity leaves traces in motion. Through these traces, the invisible becomes understandable. Not visible, but understandable. As our tools improve, we become better listeners. We notice smaller shifts, fainter motions. Each improvement adds detail to the invisible map. Yet the core message remains the same. The universe is shaped by more than what we can see, and motion is one of the quiet ways it reveals this. As we move forward, we will explore how these invisible influences connect galaxies into vast structures, stretching across the cosmos. For now, let the idea settle. Movement without noise. Paths guided by unseen weight. A universe quietly revealing its hidden parts through motion alone. Gravity as a gentle guide. Gravity is often imagined as a force that pulls things down. But in the universe, gravity works in a much quieter and more subtle way. It does not push. It does not chase. It simply shapes the paths that objects naturally follow. To understand dark matter more deeply, it helps to think of gravity not as a force, but as a guide. Everything with mass gently curves the space around it. Stars do this. Planets do this. Galaxies do this. Dark matter does this as well. Even though dark matter cannot be seen, its mass still shapes space. And once space is shaped, motion follows naturally. Objects move along the curves that gravity creates. They are not being dragged. They are simply following the easiest paths available. This is why galaxies do not feel chaotic. They feel calm and organized. Dark matter creates large, smooth gravitational landscapes. Within these landscapes, stars and gas move comfortably, as if sliding along invisible slopes. One interesting fact is that dark matter does not create sharp gravitational peaks. Unlike stars or planets, which concentrate mass in small regions, dark matter spreads itself out. This creates wide, gentle gravitational fields rather than steep ones. Because of this, motion remains smooth. There are no sudden changes. No abrupt turns. This is one reason galaxy rotation curves appear so flat and stable. Dark matter also plays a role in keeping galaxies from collapsing inward. While gravity pulls everything together, the motion of stars balances this pull. Dark matter provides the background gravity that allows this balance to exist. Another fascinating detail is that dark matter was likely the first structure-forming substance in the universe. In the early cosmos, ordinary matter was hot and energetic. It moved too quickly to clump together. Dark matter, however, did not interact with light. It cooled more easily. It began forming gentle gravitational wells long before stars existed. Later, ordinary matter slowly fell into these wells. Stars formed inside them. Galaxies grew around them. In this way, dark matter acted as a quiet architect of the universe. It did not build structures directly. It created the conditions that allowed structures to form. Even today, this guiding role continues. Galaxies move along invisible pathways shaped by dark matter. Clusters form where dark matter concentrations overlap. The large-scale structure of the universe follows these hidden patterns. There is something deeply calming about this process. Nothing is forced. Nothing is rushed. Dark matter does not command the universe. It gently suggests where things may go. Gravity, guided by dark matter, becomes a quiet language. A language spoken over billions of years. A language written in motion rather than sound. Scientists often describe this as the universe, remembering its early structure. Dark matter preserves those early patterns and carries them forward through time. Even as stars are born and die, even as galaxies change shape, the dark matter framework remains. Steady, patient, unchanged. This is why gravity, when viewed through dark matter, feels less like a force and more like a presence. A background influence. A gentle guide. As we continue, we will explore how this invisible guidance connects galaxies into vast networks, stretching quietly across the universe. For now, rest with this thought. Nothing is being pulled aggressively. Nothing is being controlled. Everything is simply following the quiet curves laid out by something unseen, steady, and endlessly patient. Mass without light. In everyday life, mass and light often feel connected. Heavy objects usually feel solid. Solid things usually reflect light. We learn to associate presence with visibility. But the universe gently teaches us that this connection is not required. Dark matter is mass without light. It adds weight to the universe without adding brightness. It contributes to gravity without contributing to glow. This idea is simple, yet deeply unusual. When scientists talk about mass, they are not talking about how something looks. They are talking about how strongly it influences motion, how much it bends space, how firmly it holds other things nearby. Dark matter does all of this quietly. It does not shine like stars. It does not burn like gas. It does not reflect like planets. And yet, it outweighs all visible matter combined. One of the most interesting facts about dark matter is that it makes up most of the mass in galaxies. Stars, planets, and glowing gas account for only a small portion of what is actually there. This means that when we look at a galaxy, we are seeing only a thin outline of its true form. The bright parts are like scattered lights on a much larger, invisible structure. The real shape of a galaxy is defined by mass, not light. Dark matter creates this hidden shape. It forms a vast, rounded presence around galaxies, extending far beyond their visible edges. Within this presence, gravity remains steady and calm. This also explains why galaxies look the way they do. Spiral arms remain stable. Elliptical galaxies stay smooth. The overall structure persists over long periods of time. Without dark matter, these shapes would not last. Another interesting detail is that dark matter does not seem to clump on small scales. It does not form dense knots the way stars do. It remains spread out, smooth, and evenly distributed. This smoothness is important. It prevents sudden gravitational disturbances. It keeps motion predictable. It allows galaxies to evolve slowly instead of violently. In a sense, dark matter acts like a cushion. It absorbs change by spreading gravity evenly. This is one reason why the universe feels so calm on large scales. Even dramatic events, like galaxy mergers, unfold over billions of years. Dark matter sets the pace. It also challenges our intuition. We are used to thinking that what we see is what exists. Dark matter shows us that reality can be dominated by things that never appear in our senses. This does not make the universe colder or emptier. It makes it deeper. There is comfort in knowing that the universe is supported by something quiet and consistent. Not everything needs to shine to be important. Dark matter carries mass patiently, shaping everything without asking for attention. As we continue, we will look at how this invisible mass helps maintain balance, keeping cosmic structures stable and long-lasting. For now, let this idea rest. A universe where most of what matters does not glow. A cosmos built not just on light, but on silent weight. Why motion reveals hidden things. In the universe, motion is rarely random. Objects move because something guides them. Even when the guide is invisible, its influence remains. This is why motion becomes such a powerful way to discover what cannot be seen. Dark matter does not reveal itself through light. It leaves no glow, no shadow, no outline. But it leaves something else. It leaves patterns. Every orbit, every slow drift, every steady rotation carries information about the gravity behind it. When scientists watch stars move within galaxies, they are not only observing the stars themselves, they are observing the shape of the gravitational field they move through. Motion becomes a kind of language. A language written in curves, speeds, and directions. One fascinating detail is that dark matter creates very smooth gravitational fields. These fields do not change quickly. They remain stable over immense periods of time. Because of this, motion within them is also smooth. Stars do not suddenly speed up or slow down. Their paths remain consistent. This consistency allows scientists to rule out many possibilities. If dark matter were clumpy or violent, motion would show signs of disturbance. But it does not. Instead, motion tells us that dark matter is evenly spread and quietly persistent. Another interesting fact is that dark matter influences motion even when ordinary matter is absent. In regions of space with few stars, galaxies still move as if mass is present. This shows that gravity does not follow light. It follows mass. By comparing where light is and where motion suggests mass exists, scientists can see the mismatch clearly. This mismatch is one of the strongest pieces of evidence for dark matter. Motion also helps scientists understand how structures formed over time. By tracing how galaxies move today, they can reconstruct how they must have moved in the past. These reconstructions show that dark matter guided structure formation from the beginning. It acted as a gravitational framework long before stars existed. Even now, motion continues to trace these ancient patterns. Galaxies drift along invisible filaments of dark matter. Clusters move where dark matter density is highest. This creates a vast cosmic network, hidden from view but revealed through movement. There is something elegant about this method of discovery. Nothing needs to be forced. Nothing needs to be disturbed. Scientists simply watch and listen to the universe through motion. This teaches a gentle lesson. Some things reveal themselves not by being seen, but by shaping how everything else moves. Dark matter may be invisible, but its influence is written everywhere in the slow choreography of the cosmos. As we move forward, we will explore how this invisible influence creates balance, allowing the universe to remain calm instead of chaotic. For now, let motion be enough. Slow orbits, gentle drifts, paths guided by something unseen, yet always present. Balance in a calm universe. The universe often appears quiet and stable. Galaxies persist for billions of years. Clusters remain bound across vast distances. Nothing seems to fall apart suddenly. This calmness is not accidental. It comes from balance. Balance in the universe is created when motion and gravity gently match each other. Objects move just fast enough to avoid collapse, and just slow enough to remain connected. Dark matter plays a central role in this balance. Without it, gravity from visible matter alone would be too weak. Structures would slowly unravel. Stars would drift away from their galaxies. With dark matter present, gravity becomes evenly distributed. It supports motion without overwhelming it. This balance is not fragile. It is robust and long-lasting. One interesting fact is that dark matter helps prevent extreme behavior. Because it is spread out smoothly, it avoids creating sharp gravitational spikes. This reduces chaos on large scales. In a universe dominated only by visible matter, interactions would be more violent. Gas would collapse more quickly. Galaxies would change shape more often. Dark matter slows these processes down. It stretches change over long periods of time. This gives the universe its gentle pace. Another important detail is that balance does not mean stillness. Everything is moving. But everything moves within limits. Stars orbit. Galaxies rotate. Clusters drift. Dark matter sets the boundaries within which this motion occurs. This balance also allows life to exist. Galaxies remain stable long enough for stars to form and shine steadily. Planetary systems can develop without constant disruption. While dark matter does not interact directly with life, it creates the conditions that make stability possible. There is something deeply reassuring about this. The universe is not constantly on the edge of collapse. It is supported by something steady and reliable. Dark matter does not fluctuate wildly. It does not change quickly. It provides a consistent gravitational background. This consistency is what allows complexity to grow slowly. Over billions of years, small changes accumulate. Stars form and die. Elements spread through space. Structures evolve. All of this happens within a balanced framework. Dark matter is like a quiet foundation beneath a vast structure. It does not draw attention. It does not decorate the surface. But without it, nothing above would stand. As we continue, we will look at how this balance emerged in the early universe, and how dark matter helped shape the first cosmic structures. For now, let this idea settle. A universe that moves, but does not rush. That changes, but does not collapse. Held in balance by something invisible, calm, and patient. Why dark matter feels silent? Dark matter is often described as mysterious, but a better word might be quiet. It does not announce itself. It does not produce signals that demand attention. It simply exists. This silence is not emptiness. It is presence without noise. In the universe, many things are loud in their own way. Stars burn and release energy. Supernovae explode. Black holes distort space dramatically. Dark matter does none of these things. It does not shine. It does not heat up. It does not erupt. Its influence is steady and constant. One reason dark matter feels silent is because it does not interact with light or sound. Light passes through it. Sound does not exist in space. There are no waves or flashes to mark its presence. Instead, dark matter works through gravity, which operates quietly at a distance. Gravity does not create noise. It does not require contact. It simply shapes motion. Because of this, dark matter can shape the universe without creating disturbance. Another reason for this silence is scale. Dark matter operates on very large scales. Its effects are spread across entire galaxies and clusters. Nothing changes quickly. When something changes slowly, it feels quiet. There are no sudden events. No sharp transitions. Only gradual evolution over billions of years. This makes dark matter easy to overlook. Human senses are tuned to quick changes. We notice flashes, sounds, movement. We are less sensitive to things that act steadily and patiently. Dark matter exists outside our usual rhythm. It does not compete with visible matter. It does not interfere with everyday processes. It allows stars and galaxies to follow their paths without interruption. There is also an important scientific reason for its silence. Dark matter particles, whatever they are, appear to interact very weakly. They rarely collide. They rarely exchange energy. This lack of interaction keeps them quiet. They do not produce heat. They do not generate light. They do not create detectable signals. Yet this same silence makes dark matter long-lasting. Because it does not lose energy, it remains stable over cosmic time. It does not decay quickly. It does not change form. This stability allows dark matter to act as a steady background for the universe. It is always there, always supporting, never demanding attention. In a way, dark matter resembles silence itself. Silence is not nothing. It is a space in which things can exist without distraction. Dark matter creates a similar space in the universe. A calm foundation on which everything else unfolds. As we continue, we will look back in time, to the early universe, and see how this quiet presence helped shape the first structures that would later become galaxies. For now, rest with the idea. A universe guided not only by light and energy, but by something silent, patient, and endlessly present. Dark matter in the early universe. Long before stars existed, before galaxies formed, the universe was very different. There was no light to guide the eye. No glowing structures to observe. Everything was hot, dense, and slowly expanding. In those earliest moments, dark matter was already present. While ordinary matter interacted strongly with light and energy, dark matter remained calm and detached. It did not heat up in the same way. It did not scatter light. This difference mattered. As the universe expanded and cooled, ordinary matter was still restless. It moved quickly, pushed around by radiation. It could not easily settle into stable structures. Dark matter behaved differently. Because it did not interact with light, it began to slow down earlier. It started to gather gently under its own gravity. These early gatherings were not stars or planets. They were invisible concentrations of mass. Small at first. Soft in their influence. But important. Over time, these concentrations deepened. They formed gentle gravitational wells across the young universe. Ordinary matter, still energetic, began to notice these wells. It slowed as it passed through them. It lingered. Eventually, it began to fall inward. This is how dark matter quietly shaped the universe before anything could shine. Galaxies did not form randomly. They formed where dark matter had already prepared a place. In this sense, dark matter was the universe's first architect. It did not build visible structures. It shaped the invisible framework on which everything else would grow. This process took immense time. Nothing happened quickly. Millions of years passed in silence. But the result was profound. The universe developed a large-scale structure. Filaments of dark matter stretched across space. Between them, vast empty regions formed. Ordinary matter followed these paths. Gas collected along dark matter filaments. Stars formed where matter became dense enough. Galaxies lit up along the invisible skeleton laid out long before. Even today, this ancient structure remains. The positions of galaxies trace the shape of dark matter. Clusters sit at intersections of invisible filaments. The universe still remembers its quiet beginning. What is remarkable is how little dark matter has changed since then. It does not age in the way stars do. It does not burn or decay noticeably. It remains much as it was, continuing to guide structure without interference. This long memory gives the universe stability. The early patterns persist. The overall shape remains coherent. Dark matter does not rush the universe toward complexity. It allows complexity to unfold slowly. As we move forward, we will explore how this invisible framework connects galaxies into a vast cosmic web, stretching quietly across the universe. For now, let this idea rest. Before there was light, before there were stars, there was something silent, already shaping the future. The cosmic web explained calmly. When we imagine the universe, it is easy to picture stars scattered randomly across empty space. But when scientists step back and look at the universe on the largest scales, a different picture appears. The universe is not scattered. It is connected. Galaxies are arranged along vast, invisible threads. These threads stretch across millions of light years, linking clusters together. Between them lie enormous empty regions, calm and quiet. This structure is called the cosmic web. And dark matter is what shapes it. Long before galaxies formed, dark matter began gathering into gentle filaments. These filaments did not shine. They did not glow. But they created paths of gravity across space. Ordinary matter followed these paths. Gas drifted along the invisible lines. Over time, it collected where filaments crossed. These intersections became the birthplaces of galaxies and clusters. In this way, dark matter quietly laid out a map for the universe to follow. The cosmic web is not rigid. It does not pull tightly or forcefully. It is soft, flexible, and patient. Galaxies move slowly along these dark matter threads, guided rather than pushed. Nothing happens suddenly. Everything unfolds over immense periods of time. One fascinating detail is that most of the universe's matter lies not inside galaxies, but between them. Much of this matter is dark matter, stretched thin across the web. The bright parts of the universe are like small lights on a vast, invisible network. When scientists simulate the universe using computers, the cosmic web appears naturally when dark matter is included. When dark matter is removed, the web disappears. Structure collapses into randomness. This tells us something important. The cosmic web is not an accident. It is a natural result of dark matter's quiet influence. Even today, galaxies continue to move along this ancient structure. Their positions are not random. They reflect the invisible pattern laid down billions of years ago. The web also explains why some regions of space feel so empty. These voids are not failures of formation. They are natural spaces between dark matter filaments. Nothing is missing there. The universe simply arranged itself differently. There is something deeply peaceful about this image. A universe held together not by rigid walls, but by soft connections. A structure that supports without constraining. Dark matter does not trap galaxies. It gives them paths. The cosmic web is a reminder that even on the largest scales, the universe prefers balance over chaos. Connection over isolation. Slow growth over sudden change. As we move forward, we will look more closely at what lies between these filaments, and why empty space is not truly empty at all. For now, let the image rest. A vast, invisible web stretching across the cosmos. Galaxies drifting gently along its threads. Everything connected by something unseen, yet deeply real. Dark matter between galaxies. When we look at images of space, our eyes are naturally drawn to bright things. Stars. Galaxies. Glowing clouds of gas. Between these lights, there appears to be a great emptiness. But this space between galaxies is not truly empty. It is quiet. It is dark. But it is filled with invisible presence. Much of this space is occupied by dark matter. Dark matter does not stay only inside galaxies. It extends far beyond them. It fills the regions between galaxies, stretching across the vast distances that separate visible structures. This is one reason why galaxies do not drift apart freely. Even when they seem isolated, they are still connected by invisible gravity. Dark matter creates a gentle background pull that spans enormous distances. It does not tug sharply. It does not hurry. It simply keeps everything aware of everything else. In these intergalactic regions, dark matter is spread thin. It does not form dense concentrations. It remains smooth and calm. Yet even this thin presence matters. Over millions and billions of years, small influences add up. The slow pull of dark matter guides how galaxies move relative to one another. This helps explain why galaxies often appear in groups and clusters rather than alone. They are following invisible contours in space. Another interesting fact is that dark matter in these regions likely existed before galaxies themselves. The galaxies grew inside a pre-existing dark matter landscape. In that sense, galaxies are guests in a space shaped long before they arrived. The space between galaxies also contains faint ordinary matter. Thin gas spread so widely that it barely glows. This gas follows the same dark matter patterns. Together, visible and invisible matter create a quiet continuity across the universe. Nothing is truly isolated. Even the most distant galaxy is still part of a larger gravitational conversation. This does not mean galaxies are constantly interacting. Most of the time, the influence is subtle, barely noticeable on human timescales. But over cosmic time, these gentle connections shape the universe. They guide mergers. They influence alignment. They affect long-term motion. Dark matter between galaxies acts like a soft field rather than a collection of objects. It does not demand attention. It does not form boundaries. It simply exists everywhere it needs to be. There is something calming about this idea. The universe is not made of separate islands floating in emptiness. It is a connected whole, held together by something invisible and patient. Dark matter fills the gaps. It smooths transitions. It ensures continuity. As we continue, we will explore why these vast spaces, though filled with invisible mass, still feel so empty and quiet to us. For now, let this thought settle. Between every light in the universe, there is something unseen, gently holding everything together. Why empty space is not truly empty. When we imagine empty space, we often think of nothing at all. No matter. No energy. No influence. But in the universe, true emptiness is rare. Even the vast spaces between galaxies contain quiet activity. Dark matter is one of the reasons space is never completely empty. It does not fill space in a visible way. It does not glow or shimmer. But it contributes mass and gravity wherever it exists. This means that space itself carries weight. Alongside dark matter, space also contains faint gas, radiation, and energy left over from the early universe. These components are spread so thin that they barely register, yet they are present. Together, they create a background that shapes cosmic behavior. Dark matter plays a central role in this background. Because it is spread smoothly, it creates gentle gravitational fields across even the emptiest regions. These fields are not strong enough to create visible structures, but they are strong enough to influence motion. Galaxies feel these influences as they drift. Clusters feel them as they remain bound. Empty space becomes a quiet participant rather than a passive void. One interesting fact is that dark matter helps define where structures do not form. The vast empty regions, called cosmic voids, are not accidents. They are natural outcomes of how dark matter arranged itself early on. In these voids, dark matter density is lower. As a result, ordinary matter had little reason to gather there. This does not mean nothing exists in voids. It means things exist quietly and sparsely. Void regions still contain dark matter. They still contain faint gas. They still feel gravity. They are simply calm places in the universe. This calmness gives the universe its contrast. Dense regions feel rich and complex. Empty regions feel open and peaceful. Both are equally important. Dark matter helps maintain this balance. It prevents matter from collapsing everywhere. It allows some regions to remain empty. This balance creates variety without chaos. It also means the universe has room to breathe. Nothing is overcrowded. Nothing is forced into every corner. The presence of dark matter ensures that emptiness is structured, not random. Even when nothing seems to be happening, something is quietly at work. As we move forward, we will explore how scientists search for dark matter directly, listening patiently for its rare interactions. For now, let this idea settle. Space is not a blank canvas. It is a subtle background, shaped by invisible mass, quietly influencing everything within it. How scientists look for dark matter. Because dark matter does not shine, reflect light, or interact easily, searching for it requires a very different approach. Scientists cannot simply point a telescope and look. Instead, they listen patiently. One way scientists search for dark matter is by building experiments designed to detect its rare interactions with ordinary matter. These experiments are quiet by necessity. They are placed deep underground, far away from noise caused by cosmic rays and human activity. Thick layers of rock shield them from interference. The deeper the experiment, the calmer the environment. Inside these detectors, scientists wait for something extremely subtle. A tiny transfer of energy. A small movement of an atom. A brief signal that suggests dark matter passed through and interacted. Most of the time, nothing happens. This silence is expected. Dark matter interacts very rarely. Days, months, or even years can pass without a single event. But patience is part of the process. Each moment of quiet tells scientists something important. It narrows the possibilities. It helps rule out what dark matter is not. Another method of searching involves creating dark matter in powerful particle accelerators. By smashing particles together at high energies, scientists hope to produce dark matter particles that briefly appear and then vanish. These particles would not be seen directly. Instead, scientists look for missing energy, clues that something invisible carried energy away. Again, the signs are subtle. Nothing dramatic. Just careful accounting. Scientists also search for dark matter in space. They look for faint signals that might come from dark matter particles interacting with each other. This could produce gentle radiation or particles that telescopes can detect. So far, no clear signal has been confirmed. But the search continues calmly. What makes this search different from many others in science is its patience. There is no rush. There is no expectation of quick results. Dark matter has existed for billions of years. It will not disappear if it is not found immediately. This long view shapes how scientists work. Experiments are designed to run quietly for years. Data is collected slowly. Results are checked carefully. Even when no detection occurs, the knowledge gained is valuable. Each experiment refines our understanding. Each quiet result guides the next question. There is something fitting about this process. Dark matter works silently, and so does the science that seeks it. As we continue, we will explore why not finding dark matter directly has still taught us a great deal about its nature. For now, let this idea rest. A search conducted in silence. Questions asked without urgency. Understanding growing slowly, one quiet moment at a time. Deep underground experiments. To study something as quiet as dark matter, scientists must find places that are even quieter. The surface of Earth is full of activity. Cosmic rays pass through constantly. Radiation from space and the Earth itself creates background noise. To escape this noise, researchers go deep underground. Miles beneath mountains, inside old mines, and below thick layers of rock, special laboratories have been built. These places are among the calmest environments on Earth. The rock above acts like a shield. It blocks most of the particles that would otherwise interfere with sensitive detectors. Inside these underground spaces, instruments wait patiently. They are designed to notice incredibly small events. A single atom moving. A faint flash of light. A tiny vibration. These signals, if they appear, could indicate that a dark matter particle has passed through and interacted briefly. The detectors themselves are often made of extremely pure materials. Liquid crystals. Ultra-clean metals. Substances cooled to very low temperatures. Everything is controlled carefully. Temperature. Vibration. Electromagnetic interference. Nothing is allowed to disturb the silence. This level of care is necessary because dark matter interactions are expected to be incredibly rare. If dark matter passes through Earth constantly, it does so without touching much. Only once in a great while might it interact strongly enough to be noticed. When an experiment runs for months or years without detecting anything, this is not a failure. It is information. It tells scientists that dark matter interacts even less than previously thought. It helps refine theories. It narrows the search. There is something almost meditative about these experiments. Machines waiting in silence. Data accumulating slowly. Scientists observing patterns that may take years to emerge. Dark matter does not rush, and neither does the science built to understand it. These underground experiments represent a kind of scientific patience that is rare in other fields. They accept uncertainty. They allow time to pass. In doing so, they reflect the nature of the universe itself. The universe unfolds slowly. Its deepest structures change over billions of years. To study such a universe, scientists must learn to wait. As we continue, we will see how this patience extends to detectors that listen quietly for years, hoping to catch even the faintest whisper of dark matter. For now, let this image rest. Deep beneath the Earth, in perfect stillness, machines wait for something invisible to pass by. Quiet detectors waiting patiently. Dark matter experiments are not built to observe dramatic events. They are designed to notice almost nothing. A detector might wait for months without recording a single meaningful signal. And that is expected. These detectors are like listeners in a silent room, waiting for a sound that may never come. When something finally does happen, it will be faint, brief, and easy to miss. To prepare for this, detectors are built with extraordinary sensitivity. They are tuned to detect the smallest possible interactions. A tiny flash of light. A slight vibration. A small shift in energy. Even these subtle signs must be separated from background noise. This is why detectors are isolated so carefully. Every possible source of interference is removed or minimized. Materials are selected for purity. Electronics are shielded. Environments are stabilized. The goal is to create silence so complete that even the quietest event stands out. One fascinating fact is that many detectors are designed to measure energy far smaller than anything we experience in daily life. The energy involved may be millions of times weaker than a single grain of sand falling, and yet, these tiny energies can carry profound meaning. If a dark matter particle interacts, it may transfer just enough energy to be noticed. But such interactions are rare. This rarity tells scientists something important about dark matter. It suggests that dark matter does not interact strongly with ordinary matter. It confirms the idea that dark matter is mostly detached from the visible world. The weighting itself becomes a form of measurement. Every moment without detection tightens the limits on what dark matter can be. Every quiet day removes possibilities. There is a calm discipline in this process. No rushing. No forcing results. Scientists must trust that understanding will come through patience. These detectors often run for years. Data accumulates slowly. Analysis is careful and deliberate. Sometimes, a signal appears that later turns out to be noise. This is not disappointment. It is part of learning. False signals teach scientists how to improve their instruments. They refine their methods. They adjust their expectations. Dark matter remains silent, but the science around it becomes sharper. There is something almost poetic about this, a quiet universe. Quiet experiments. Quiet progress. The search for dark matter mirrors its subject. It rewards those who are willing to listen without impatience. As we move forward, we will explore how even not finding dark matter has helped scientists understand the universe more clearly. For now, let the silence remain. A detector waiting in darkness. Time passing gently. Knowledge growing, one quiet moment at a time. Learning from what we do not find. In science, discovery does not always come from finding something. Sometimes it comes from not finding it. Dark matter research is a clear example of this quiet truth. Many experiments have searched for dark matter directly. They have waited patiently. They have listened carefully. And often, they have found nothing. This absence of detection is not empty of meaning. Each experiment is designed with certain expectations. If dark matter behaved in a particular way, the detector would notice it. When nothing appears, those possibilities gently fade away. This process is slow, but powerful. By ruling out what dark matter is not, scientists narrow the space of what it could be. This has already taught us many things. We know that dark matter does not interact strongly with light. We know it does not interact strongly with ordinary matter. We know it does not produce easily detectable radiation. These conclusions did not come from dramatic discoveries. They came from careful listening and quiet patience. There is a calm honesty in this approach. Science does not force answers. It allows reality to speak in its own time. Dark matter has remained silent, but its silence has shape. It has boundaries. It has limits. These limits help guide new ideas and new experiments. Scientists adjust their models. They refine their questions. They explore alternative possibilities. Some ideas are gently set aside. Others are examined more closely. This process mirrors the universe itself. The universe does not rush. It does not reveal everything at once. It unfolds slowly. By accepting silence as information, scientists align themselves with this rhythm. They learn to value patience over speed. There is also something comforting about this kind of knowledge. Not knowing everything does not mean knowing nothing. Understanding grows even in uncertainty. Dark matter reminds us that the universe is not obligated to be simple or immediate. Some truths take time. Some remain partially hidden. And that is acceptable. As we continue, we will explore how this quiet search has shaped new ideas about what dark matter might be, and how future research may continue in the same patient spirit. For now, let this thought rest. Sometimes, the most meaningful answers come not from what appears, but from what remains quietly unseen. Invisible things that shape reality. Much of what shapes our world is not directly visible. Air moves around us, yet we cannot see it. Gravity holds us to the earth, yet we do not see it. Dark matter belongs to this quiet family of invisible influences. It does not appear in images. It does not announce itself through light or sound. Yet it shapes the largest structures in the universe. This idea challenges a common assumption that what is real must be visible. In the cosmos, visibility is optional. Dark matter reminds us that reality is defined by influence, not appearance. Galaxies move the way they do because dark matter is present. Clusters remain bound because dark matter adds weight. The cosmic web exists because dark matter shaped it early on. None of this requires light. This realization has changed how scientists think about the universe. They no longer rely solely on observation by sight. They look for patterns, effects, and relationships. Dark matter becomes a lesson in indirect understanding. We know it exists not because we see it, but because the universe behaves as if it does. This kind of reasoning is careful and restrained. It avoids assumptions. It respects uncertainty. It also requires humility. The universe is not built only from things that match human senses. It contains components that lie beyond direct experience. Dark matter is one of these components. Its existence suggests that there may be other invisible influences still unknown. Forces, particles, or structures that quietly shape reality. This does not make the universe frightening. It makes it richer. There is comfort in knowing that not everything needs to be fully understood to be meaningful. Dark matter has shaped galaxies long before humans existed. It continues to do so without awareness of observation. Its work does not depend on recognition. In a way, dark matter invites us to rethink importance. Something can matter deeply without being noticed. Something can support everything without ever being seen. As we move toward the later chapters of this journey, we will explore how scientists think about the future of dark matter research, and what questions remain open. For now, let this idea settle. Reality is larger than what appears. The universe is guided by things that do not seek attention, and among them, dark matter stands as a quiet example of unseen influence. Why the universe does not collapse. At first glance, gravity might seem like a force that should eventually pull everything together. Stars should fall into galaxies. Galaxies should fall into clusters. Clusters should collapse inward over time. And yet, the universe remains open, spacious, and stable. This balance between attraction and expansion is one of the quiet achievements of dark matter. Dark matter adds gravity, but not in a way that causes sudden collapse. It spreads mass smoothly across space, avoiding sharp concentrations. This smooth distribution matters. When gravity is evenly spread, it creates balance rather than chaos. Structures remain bound, but they do not collapse inward uncontrollably. Dark matter holds galaxies together without forcing them to shrink. It allows motion to remain steady. At the same time, the universe itself is expanding. Space is stretching slowly, carrying galaxies apart. Dark matter does not resist this expansion completely. It works within it. On small scales, like galaxies and clusters, gravity dominates. On larger scales, expansion becomes more important. This layered behavior creates stability. Nothing is pulled together too tightly. Nothing drifts apart too quickly. Dark matter helps define these boundaries. It keeps structures intact where they need to be, while allowing the universe as a whole to grow. This balance has existed for billions of years. It is not temporary. It is sustained. Another interesting fact is that dark matter does not clump in a way that creates runaway collapse. It lacks the interactions that cause ordinary matter to cool and fall inward rapidly. Because of this, dark matter avoids forming extremely dense objects. This prevents excessive gravitational focusing. In simple terms, dark matter provides support without pressure. It adds weight without compression. This is one reason the universe does not turn into a single massive object. The presence of dark matter allows structure without domination. It supports complexity while preserving openness. There is a quiet elegance in this outcome. The universe is neither chaotic nor rigid. It is balanced. Dark matter contributes to this balance not by acting forcefully, but by being present everywhere in moderation. As we continue, we will look toward the future and consider how dark matter may continue shaping the universe long after stars have faded. For now, let this idea rest. A universe that holds together without collapsing. Expansion and gravity in calm conversation. Stability maintained by something unseen, yet essential. Dark matter and the long future of the cosmos. When we think about the future of the universe, our minds often turn to dramatic ideas. Stars burning out. Galaxies drifting apart. Light fading into darkness. But the future shaped by dark matter is not dramatic. It is slow, quiet, patient. Dark matter does not change quickly. It does not burn fuel. It does not age in a visible way. It remains much the same as it has been for billions of years. Because of this, dark matter will likely outlast many of the things we see today. Stars will exhaust their fuel and fade. Galaxies will slowly change shape. Bright structures will grow dim. Through all of this, dark matter will continue to exist, quietly guiding motion. In the far future, galaxies may become more isolated. The expansion of space will gently carry them farther apart. Light from distant regions will take longer and longer to arrive. Yet within each galaxy, dark matter will still provide structure. Stars that remain will continue to orbit calmly. Remnants of galaxies will stay bound. Local systems will remain stable. Dark matter does not resist change, but it also does not encourage collapse. It allows the universe to evolve without rushing it toward an end. Another interesting thought is that dark matter may preserve memory. The large-scale structure of the universe today reflects patterns set down in its earliest moments. As time passes, these patterns may soften, but they will not disappear entirely. Dark matter acts like a quiet archive. It holds on to the shape of the universe's past. Even as visible matter changes form, the invisible framework remains. In some models of the future, star formation will slow and eventually stop. The universe will become darker, colder, and more still. In such a universe, dark matter will not suddenly become active or visible. It will remain what it has always been: a calm background presence. This makes dark matter different from many other cosmic components. Energy transforms. Matter changes state. Radiation fades. Dark matter persists. There is a certain comfort in this idea. The universe is not rushing toward disappearance. It is stretching, relaxing, and settling into a quieter state. Dark matter supports this gradual transition. It does not demand attention. It does not accelerate endings. It allows time to pass gently. Some scientists wonder whether dark matter itself may change over extremely long timescales. Perhaps it decays very slowly. Perhaps it transforms in ways we do not yet understand. If it does, those changes will be subtle and spread across immense periods of time. Nothing sudden. Nothing loud. Dark matter teaches us to think in deep time. Time measured not in years or centuries, but in billions and trillions of years. In this scale, urgency disappears. Processes unfold at their own pace. The future shaped by dark matter is not one of destruction. It is one of continuation. Structures may simplify. Light may fade. But balance remains. Dark matter does not promise permanence of brightness. It offers persistence of form. And in that persistence, the universe finds calm. As we move closer to the later chapters, we will begin to reflect more deeply on what dark matter means for understanding reality itself, and how it reshapes our sense of what is important. For now, let this thought rest. A universe growing quieter with time. Dark matter still present. Still holding. Still guiding, long after the lights have dimmed. How dark matter shapes what we call reality. When we think about reality, we usually think about what we can touch, see, or measure directly. Objects feel real because they reflect light, take up space, and respond to our actions. For a long time, science followed the same instinct. If something could not be seen, it was often ignored. Dark matter quietly changed this way of thinking. It showed scientists that reality does not need to announce itself. Something can exist, influence everything around it, and still remain hidden from direct observation. Dark matter shapes reality by shaping space itself. Where dark matter gathers, gravity becomes stronger. Where gravity becomes stronger, matter follows. And where matter follows, structure appears. Galaxies exist where dark matter allows them to exist. clusters form where dark matter creates deep gravitational regions. Even the large-scale pattern of the universe reflects the invisible layout of dark matter. This means that much of what we experience as structure is not primary. It is secondary. The visible universe is like a surface pattern formed by something deeper. Dark matter does not create stars directly. It does not light galaxies. But without it, those things would not appear in their familiar forms. Another interesting fact is that dark matter helps define what we consider normal physics. The laws of motion we observe in galaxies make sense only when dark matter is included. Without dark matter, these laws would seem broken. Objects would move too fast. Structures would dissolve. Dark matter quietly restores balance. In this way, dark matter becomes part of the background rules of reality. It sets conditions that everything else must follow. This has philosophical implications as well. If most of the universe is invisible, then reality is not limited to appearance. It extends beyond perception. Dark matter reminds us that knowledge does not always come from direct experience. Sometimes it comes from patterns, relationships, and consistency. This changes how scientists approach questions. Instead of asking only, "What can we see?" they ask, "What must exist for this behavior to make sense?" Dark matter is an answer to that question. It also humbles our perspective. Human senses evolved to understand a small part of the universe. They are not designed to perceive everything that exists. Dark matter exists comfortably outside that range. And yet, it does not resist understanding. It allows itself to be known indirectly. Through gravity. Through motion. Through structure. This indirect knowledge is still real knowledge. In fact, it is often more reliable. It depends on consistency rather than impression. On repeated patterns rather than isolated events. Dark matter behaves the same way everywhere we look. Across galaxies. Across clusters. Across the observable universe. This uniformity strengthens its role in shaping reality. It tells us that dark matter is not a local trick. It is a universal component. As our understanding grows, dark matter becomes less of a mystery and more of a quiet foundation. Not something exotic or threatening, but something ordinary on a cosmic scale. It is simply part of how the universe works. As we approach the final stages of this journey, we will begin to explore the unanswered questions that remain, and why uncertainty itself plays an important role in scientific understanding. For now, let this idea settle. Reality is not only what shines. It is also what holds. And sometimes, what holds everything together is something we never see at all. Calm uncertainty in science. Science is often imagined as a search for final answers. Clear explanations. Definite conclusions. But in reality, science lives comfortably with uncertainty. Dark matter is one of the clearest examples of this calm uncertainty. For decades, scientists have known that dark matter exists. They have measured its effects. They have mapped its influence. And yet, its true nature remains unknown. This does not weaken scientific understanding. It strengthens it. Uncertainty in science is not confusion. It is awareness of limits. Scientists know what dark matter does. They know how it behaves on large scales. They know how it shapes galaxies and clusters. What they do not yet know is what dark matter is made of. This gap in knowledge is not a failure. It is a space for careful thought. Rather than rushing to fill this space, science treats it gently. Ideas are proposed. They are tested. Some are set aside. This process happens slowly, without urgency. Dark matter teaches scientists to be patient. To accept that some questions take time. Sometimes, very long time. There is also an honesty in admitting uncertainty. Science does not pretend to know more than it does. It allows questions to remain open. This openness is essential. It prevents rigid thinking. It keeps exploration alive. Dark matter remains a question mark at the heart of cosmology. Not an alarming one. A quiet one. It invites curiosity without demanding immediate resolution. In this way, dark matter reshapes how we think about knowledge itself. Knowing something exists is not the same as knowing everything about it. And that is enough to move forward. The universe does not require us to understand it fully in order to exist, it unfolds regardless. Science simply tries to listen carefully. There is a calm humility in this approach. It recognizes that the universe is larger than human understanding, and that understanding grows gradually. Dark matter may one day be directly detected, or it may remain invisible, understood only through its effects. Either outcome is acceptable. The value lies in the process of learning, in asking careful questions, in observing patiently, in accepting uncertainty without fear. This mindset extends beyond dark matter. It shapes how scientists approach all deep questions, from the origin of the universe to the nature of time. Dark matter is a reminder that mystery and knowledge can coexist. One does not cancel the other. As we near the later chapters, we will begin to reflect more gently on what it means to live in a universe where not everything is fully known. For now, let this idea rest. Understanding does not require certainty. Curiosity does not require answers. And sometimes, the quiet unknown is part of the beauty of the universe. Dark matter and human curiosity. Human curiosity is gentle by nature. It begins with noticing, with wondering, with quietly asking why. Dark matter has existed long before humans ever looked at the sky. It shaped galaxies. It guided stars. It formed the structure of the universe without needing to be observed. And yet, once humans began to notice its effects, curiosity followed naturally. At first, dark matter was not a goal. It was a question that appeared along the way. A small inconsistency. A detail that did not fit. This is how many scientific ideas begin, not with intention, but with attention. Dark matter invites a particular kind of curiosity. Not excitement. Not urgency. But calm persistence. It does not reveal itself quickly. It does not reward impatience. It responds only to careful observation over time. This has shaped how scientists work. Instead of dramatic experiments, dark matter research favors patience. Long observations. Quiet detectors. Years of waiting. In this way, dark matter mirrors human curiosity at its best. Curiosity that is not driven by fear or urgency. Curiosity that is content to explore without demanding immediate answers. There is something deeply human about this. We look at the universe not because it owes us explanations, but because we want to understand our place within it. Dark matter does not speak directly to us, but it influences the stage on which everything else appears. By learning about dark matter, humans are not just learning about particles or gravity. They are learning about how the universe supports complexity. They are learning that reality is layered. That visible things rest on invisible foundations. This understanding changes perspective. It encourages humility. It reminds us that much of what matters operates quietly. Human curiosity thrives in this environment. It does not need certainty. It needs openness. Dark matter provides a space where curiosity can exist without pressure. There is no finish line. No final revelation promised. Only ongoing exploration. This is why dark matter remains such a compelling topic. Not because it is mysterious in a dramatic sense, but because it is quietly unresolved. It allows science to remain alive. Each generation approaches the question with new tools, new ideas, and the same calm curiosity. And through this process, humans learn something important. Understanding is not always about control. Sometimes it is about listening. Listening to motion. Listening to patterns. Listening to silence. Dark matter teaches us to value these quiet forms of attention. As we continue toward the final chapters, we will reflect more deeply on what this quiet curiosity means for how we understand ourselves and the universe we inhabit. For now, let this thought settle. A universe that does not rush to explain itself. And a human curiosity patient enough to keep listening. Knowing without seeing. Most of what we know in daily life comes through sight. We trust what we can see. We rely on images to confirm reality. But dark matter gently challenges this habit. It asks us to know something without ever seeing it. This is not unfamiliar. We already accept many unseen things. We trust gravity without seeing it. We believe in time without observing it directly. Dark matter joins this quiet group of accepted realities. Scientists know dark matter exists because the universe behaves as if it does. Motion follows its influence. Structures depend on its presence. This kind of knowing is indirect, but strong. It is built on patterns that repeat, on observations that align, on explanations that remain consistent. Dark matter does not appear once and vanish. Its effects are seen everywhere. In this way, it becomes reliable. Knowing without seeing requires trust in process, careful measurement, slow verification. This approach removes emotion from understanding. There is no excitement required, no belief, only consistency. Dark matter also teaches us that reality is not limited to perception. Our senses evolved for survival, not for cosmic understanding. The universe is under no obligation to be visible. This realization expands how we define truth. Truth becomes something that can be inferred, not just observed. Dark matter shapes galaxies whether we acknowledge it or not. Its influence does not depend on recognition. This independence gives it a quiet authority. It does not persuade. It does not convince. It simply acts. There is something calming in this. Reality exists beyond opinion, beyond attention. Dark matter invites us to accept that some things are real simply because they work. They hold structures together. They guide motion. They provide stability. Seeing is not required. As we approach the final chapters, this idea becomes more important. Understanding the universe does not always mean revealing everything. Sometimes it means accepting that some parts remain unseen. Dark matter stands as a reminder of this. It shows us that knowledge can be quiet, that certainty can be gentle, and that the universe is larger than our senses. For now, let this thought rest. To know something deeply, without ever seeing it, is not a weakness, but a different kind of understanding. Dark matter as a patient companion. Dark matter has been present since the earliest moments of the universe. It existed before stars formed, before galaxies took shape, before light filled space. Through all of this, dark matter has remained calm and unchanged. It does not rush to evolve. It does not seek complexity. It simply stays. In this way, dark matter can be thought of as a patient companion to the universe. As the universe expanded and cooled, dark matter continued to guide structure quietly. It did not interfere. It did not dominate. It allowed ordinary matter to do what it does best. Stars formed. Galaxies grew. Elements were created and scattered. Dark matter remained in the background, supporting these processes without drawing attention. This patience is one of its most defining traits. Dark matter does not burn fuel. It does not exhaust itself. It does not change state dramatically. It endures. This endurance has important consequences. Because dark matter remains stable, it provides a long-term framework for cosmic evolution. Structures can develop slowly. They can persist. Without such stability, the universe would be more chaotic. This also means that dark matter will likely remain long after many visible structures fade. As stars dim and galaxies grow quiet, dark matter will still be there. Holding, guiding, supporting. There is something deeply calming about this idea. The universe is not driven only by fleeting brilliance. It is supported by something steady and reliable. Dark matter does not compete for attention. It does not demand recognition. It is content to exist quietly. This quality mirrors some of the most enduring aspects of nature. Mountains that change slowly. Oceans that move in steady rhythms. Dark matter belongs to this slow category. It reminds us that patience can be powerful. In a universe where so much changes, dark matter represents continuity. As we near the final chapters, we will reflect on how this quiet presence shapes not only the cosmos, but also how we think about permanence and change. For now, let this idea settle. A universe accompanied by something patient. Not leading. Not following. Simply present, as everything else unfolds. Why some mysteries stay quiet? Not every mystery in the universe is meant to be solved quickly. Some remain quiet for a very long time. Dark matter is one of these quiet mysteries. It does not resist understanding, but it does not hurry to explain itself. It allows observation, but only at a distance. It reveals effects, but not form. This kind of mystery is different from a puzzle waiting to be cracked. It is more like a landscape that reveals itself slowly as you walk through it. Science often celebrates answers, but it is equally shaped by unanswered questions. Dark matter reminds us of this balance. We know dark matter exists. We know where it is. We know how it behaves on large scales. What we do not know is its inner nature. This gap has remained open for decades. And that is not a failure. Some mysteries stay quiet because they are not meant to be approached directly. They require patience, new tools, and sometimes entirely new ways of thinking. Dark matter may belong to this category. It does not interact strongly. It does not leave clear signals. It does not fit neatly into existing models. Instead of forcing answers, science allows the mystery to remain. This is a strength, not a weakness. Quiet mysteries encourage humility. They remind us that the universe is not built around human curiosity. It exists on its own terms. Dark matter does not become more understandable because we want it to. Understanding must grow naturally, through careful work. This slow pace protects science from false certainty. When answers come too quickly, they are often wrong. Dark matter resists such shortcuts. It demands evidence, consistency, time. There is also a calm beauty in a mystery that does not shout. Dark matter does not create confusion. It creates space. Space to think. Space to explore. Space to accept not knowing. This acceptance changes how we relate to the universe. Instead of trying to control understanding, we learn to accompany it. To walk alongside questions rather than chase answers. Dark matter teaches us that knowledge can be partial and still meaningful. We do not need complete understanding for reality to make sense. The universe functions perfectly well without our explanations. Science simply tries to listen. There is also a deep connection between quiet mysteries and long timescales. Dark matter operates over billions of years. It does not align with urgency. Human curiosity must slow down to match it. This slowing down is part of the learning. In this way, dark matter reshapes not only cosmology, but scientific temperament. It encourages patience over speed, care over certainty, observation over assumption. As instruments improve and ideas evolve, understanding may grow, or it may remain incomplete. Both outcomes are acceptable, because the goal of science is not to remove mystery, but to understand reality as honestly as possible. Sometimes, honesty means saying, "We do not know yet." Dark matter remains a quiet companion to this statement. It exists without explanation. It influences without revealing itself. It stays calm while questions remain open. And perhaps that is exactly how some mysteries are meant to be. Not solved in a moment. Not resolved in a generation. But carried gently, as the universe continues its slow and patient unfolding. Dark matter, and the shape of what we see. When we look at the universe, we often believe we are seeing its true shape. Spiral galaxies. Elliptical clouds of stars. Clusters arranged across space. But what we see is only the visible outline. The true shape of the universe is defined by something we cannot see. Dark matter shapes the form of galaxies long before light gives them color. It determines how wide they spread, how tightly they hold together, and how they move through space. In many ways, dark matter decides the boundaries of cosmic objects. A galaxy does not end where its light fades. It ends where its dark matter halo fades. This halo is often much larger than the visible galaxy itself. Stars exist only in the inner regions. Dark matter extends far beyond. This means that when we look at a galaxy, we are seeing only a small portion of its true size. The rest exists quietly, invisible, but real. Dark matter also shapes how galaxies look from the beginning. If dark matter halos are round, galaxies tend to be smoother. If halos are slightly stretched, galaxies reflect that shape. In this way, dark matter acts like a mold. Visible matter flows into it and takes its form. Another interesting detail is that dark matter influences how galaxies align with one another. Neighboring galaxies often share similar orientations. This is not random. They are responding to the same invisible structures beneath them. Even the angles at which galaxies tilt and rotate are influenced by dark matter's distribution. This influence extends to clusters as well. Clusters are not just collections of galaxies. They are shaped by massive dark matter concentrations that define their overall structure. The visible galaxies are like decorations placed on a much larger, invisible form. This also explains why galaxy clusters often appear irregular or stretched. Their shapes reflect the underlying dark matter landscape, not just visible matter. One calm but powerful fact is that dark matter provides continuity. Visible matter changes. Stars explode. Gas moves. Galaxies merge. But dark matter remains steady. This steadiness allows structure to persist even as surface details change. Imagine a riverbank. The water flows constantly, but the shape of the land guides it. Dark matter is like that land. It does not move quickly, but it determines where motion can happen. This relationship between visible and invisible matter shows us that appearance is not the same as structure. Brightness does not define importance. Visibility does not define reality. Dark matter quietly supports everything we see. This understanding changes how scientists interpret cosmic images. They do not take pictures at face value. They ask what invisible framework lies beneath. Every observation becomes layered. Light on the surface. Gravity underneath. This layered understanding brings depth. The universe becomes more than a collection of glowing objects. It becomes a system supported by unseen foundations. Dark matter teaches us to look beyond appearance without demanding revelation. It does not need to be seen to be understood. As we approach the final chapters, this idea becomes more gentle and reflective. What we see is not wrong. It is simply incomplete. And that is not a flaw. It is an invitation to look deeper, to think more quietly, and to accept that the universe is richer than it first appears. For now, let this thought rest. A universe shaped by what we cannot see, a reality held together by invisible form, and a calm understanding that appearance is only the beginning. Dark matter and quiet meaning. As this long journey through dark matter begins to approach its end, the story naturally becomes quieter. Not because there is nothing left to say, but because understanding has settled. Dark matter no longer feels like a distant concept. It feels like a presence that has always been there. It has shaped galaxies. It has guided motion. It has supported structure without asking for attention. In doing so, it offers a quiet lesson. Not everything that matters needs to be visible. Not everything that supports reality needs to be noticed. Dark matter gives meaning to this idea in a physical way. The universe depends on something that does not shine. That does not announce itself. That does not seek recognition. This shifts how we think about importance. Brightness becomes optional. Visibility becomes secondary. What matters is influence. Dark matter influences everything we have discussed. From the smallest motions of stars to the largest structures across space. And yet, it remains silent. This silence is not emptiness. It is stability. The universe feels calm because dark matter is calm. It does not fluctuate wildly. It does not change rapidly. It provides a steady background against which everything else can evolve. There is something comforting in this. The universe is not held together by constant activity or energy alone. It is supported by something patient. This idea extends beyond cosmology. It invites reflection. In life, some of the most important things are also quiet. Foundations. Support. Presence. They work without drawing attention. Dark matter becomes a cosmic example of this truth. It does not need to be understood completely to be appreciated. It does not need to be seen to be respected. It simply needs to be acknowledged. As the story nears its final moment, the focus shifts away from facts and toward feeling. The feeling of a universe that is not chaotic, not rushed, not demanding. A universe that unfolds slowly, supported by something invisible and steady. Dark matter does not explain everything, but it makes everything possible. That may be enough. Soon, the story will come to a gentle close. Not with answers, but with acceptance. For now, let this thought rest. A universe supported by silence. Meaning carried by presence rather than appearance. And dark matter quietly holding everything together. Dark matter as a constant presence. Dark matter does not arrive at any particular moment. It does not enter the universe suddenly, and it does not leave. It simply remains. From the earliest times to the present, dark matter has been a constant presence in the background of everything we observe. While stars are born and fade, and galaxies slowly change shape, dark matter stays largely the same. It does not burn fuel. It does not grow tired. It does not transform in visible ways. This steadiness gives the universe a kind of quiet reliability. When galaxies rotate, dark matter is already there. When clusters form, dark matter has already shaped the space they will occupy. When light travels across billions of years, dark matter remains calmly in place. It does not react to events. It does not respond to explosions or collisions in the way ordinary matter does. Instead, it provides continuity. This continuity is important because the universe is not built from moments alone. It is built from persistence. Dark matter creates a background that allows change to happen without becoming chaos. One interesting detail is that dark matter does not care about scale. It works the same way whether it is guiding a small galaxy or an enormous cluster. This consistency makes it predictable, and predictability allows structure to last. Dark matter also does not compete with visible matter. It does not interfere with light, chemistry, or energy flow. It leaves those processes free to unfold naturally. In this way, dark matter acts more like space itself than like an object. It shapes the environment rather than participating in events. This is why dark matter can be present everywhere without being noticed directly. It does not demand attention. It does not announce itself. Its influence is felt only when we step back and look at long-term patterns. Another calm fact is that dark matter does not have a preferred direction or location. It does not gather in sharp points. It spreads smoothly, creating wide gravitational fields rather than narrow ones. Because of this, its presence feels gentle rather than forceful. Galaxies do not feel pulled violently. They feel supported. This gentle support allows motion to be steady. It allows orbits to be long-lasting. It allows cosmic systems to exist for billions of years without disruption. Dark matter does not guide events. It guides conditions. And conditions are what shape outcomes over time. In this sense, dark matter is less like a cause and more like a setting. It creates the stage on which everything else happens. The universe does not need dark matter to explain individual stars or planets. But it needs dark matter to explain why large structures exist at all. Without it, galaxies would not hold together. Clusters would drift apart. The universe would look very different. With it, everything feels calm and connected. Dark matter does not ask to be understood. It does not reveal itself easily. It simply remains, quietly fulfilling its role. As time moves forward, this presence does not weaken. It does not fade. Dark matter continues to be part of the universe's long memory. It remembers the early structure. It carries that structure forward. This chapter does not end with a conclusion, because dark matter does not conclude. It continues. It remains present as the universe changes slowly around it. The universe without observation. The universe does not depend on being watched. It does not wait for attention. It does not change its behavior because someone is observing. Long before there were eyes to see, the universe already existed in quiet motion. Dark matter was present then, shaping space without witnesses. Even today, most of the universe unfolds without observation. Galaxies rotate. Clusters drift. Dark matter guides motion silently, whether or not anyone notices. This raises a gentle question. What is the universe like when no one is looking? Dark matter offers a calm answer. It behaves the same way regardless of observation. It does not interact with awareness. It does not respond to attention. Its role is independent of perception. This independence suggests that reality is not created by observation. It exists on its own terms. Dark matter continues to shape structure even in regions of space no telescope will ever reach. Beyond the observable universe, it likely continues its work without interruption. There are galaxies whose light will never arrive here. Their dark matter halos still exist. Their structures remain stable. They do not need to be known to be real. This idea can feel humbling. Human observation captures only a small portion of the universe. Most of reality unfolds beyond perception. Dark matter reminds us of this quietly. It does not invite attention. It does not resist it either. It simply exists. Even within the observable universe, dark matter acts the same in places we study and places we do not. Its behavior is consistent. This consistency allows scientists to trust their models. They do not need to see everything to understand something. Dark matter also helps us understand that the universe is not performative. It does not exist to be viewed. Stars do not shine to be admired. Galaxies do not rotate to be measured. These things happen because of physical conditions, not observers. Dark matter contributes to those conditions. It provides structure without needing recognition. This perspective changes how we relate to the universe. Instead of seeing ourselves as central, we see ourselves as witnesses. Observers, not participants in cosmic behavior. Dark matter continues whether we are awake or asleep, whether we are listening or not. It does not speed up when studied. It does not slow down when ignored. It simply remains. There is peace in this thought. The universe does not depend on human presence to be complete. It does not require explanation to function. Dark matter is a reminder of that completeness. As this journey continues, we move deeper into reflection. Less about discovery, more about understanding our place within something vast and indifferent. For now, let this idea rest. A universe that exists fully on its own. Dark matter guiding structure in silence. No audience required. Time moving slowly through dark matter. Time in the universe does not move the way it feels to us. For humans, time is measured in moments, hours, and days. For the cosmos, time stretches across millions and billions of years. Dark matter lives comfortably in this slow rhythm. It does not react to short moments. It does not respond to brief changes. It exists across vast spans of time, unchanged and patient. From the earliest moments after the universe began expanding, dark matter has been present. It has watched time pass without participating in its urgency. Stars live fast lives compared to dark matter. They ignite, burn, and fade. Galaxies shift shape. Clusters slowly rearrange. Dark matter remains. This endurance allows time to unfold smoothly. Because dark matter does not decay quickly or lose energy, it provides continuity. It carries the memory of early cosmic structure forward through time. In this way, dark matter becomes a bridge between past and present. The patterns we see in galaxies today are echoes of conditions set long ago. Dark matter preserves those patterns quietly. Time passes, but the underlying structure remains recognizable. This is one reason the universe feels stable despite constant change. The visible parts evolve. The invisible foundation does not rush. Dark matter does not experience time the way matter that emits light does. It does not heat up or cool down noticeably. It does not undergo cycles. Its interaction with time is almost neutral. This neutrality allows it to act as a steady reference. While everything else changes, dark matter provides a baseline. Scientists use this stability to understand cosmic history. By observing present-day structures, they can infer how things must have been long ago. Dark matter makes this possible. Without it, the universe would lose its memory. Structures would dissolve too quickly. Patterns would fade. Time would feel more chaotic. Instead, time flows gently. Another quiet fact is that dark matter smooths time as much as it smooths space. Because it spreads mass evenly, it prevents sudden gravitational changes that would accelerate evolution. This slows cosmic processes. Galaxy formation stretches across long periods. Mergers take billions of years. Nothing happens all at once. Dark matter allows this slowness. It gives the universe room to breathe. In this slow unfolding, complexity has time to emerge. Stars form calmly. Elements accumulate. Planets appear. All of this depends on a universe that does not rush. Dark matter supports this pace. There is something peaceful in knowing that the universe is not driven by urgency. It is guided by patience. Time is not something the universe tries to escape. It is something it inhabits fully. Dark matter fits naturally into this deep time. It does not mark moments. It does not count years. It simply remains present as time passes around it. This perspective invites a different relationship with time. Not as pressure. Not as scarcity. But as space. Space in which things can happen slowly and still matter. Dark matter shows us that lasting influence does not require speed. It requires consistency. As we move forward, this understanding of time will help frame the final reflections. Not about endings, but about continuation. For now, let this thought rest. Time flowing quietly through the universe. Dark matter steady within it. Everything changing, yet something always remaining. Resting with the unknown. Now, without needing to hurry, this journey can slow to a pause. There is nothing left to solve in this moment. No final answer waiting to be revealed. No hidden detail that must be uncovered. Dark matter does not resolve itself into clarity. It remains what it has always been. Present, influential, and unseen. And that is enough. Throughout this journey, we have followed its quiet role across the universe. We have seen how it shapes galaxies without light. How it supports motion without force. How it gives structure without appearance. In doing so, dark matter has become less mysterious and more familiar. Not because it has been fully explained, but because it has been accepted. Acceptance is a gentle form of understanding. It allows questions to exist without pressure. It allows uncertainty to feel calm rather than unsettling. The universe does not ask us to comprehend everything at once. It unfolds at its own pace. Dark matter fits naturally into this unfolding. It teaches us that not all truths arrive clearly. Some remain partially hidden, working quietly in the background. This does not diminish their importance. It gives them depth. As the universe continues, stars will keep moving in slow arcs. Galaxies will drift along invisible paths. Time will pass without urgency. Dark matter will remain. Holding. Balancing. Supporting. There is comfort in knowing that the universe is not held together by constant brightness or activity alone. It is supported by something steady and patient. If rest is beginning to arrive, let it come naturally. There is nothing more to follow. The universe will continue quietly whether we are awake or asleep. Dark matter will continue its role without interruption. This is not an ending in the traditional sense. Nothing stops. Nothing concludes. It is simply a place to rest. A moment to accept that the unknown does not need to be conquered. It can be lived with. And in that quiet acceptance, understanding finds its own gentle form.